We're going to do a crash course in trigonometry. That means we're going to be covering all kinds of the basics, all the big ideas in short, easy to understand units. We're going to do 3 of them. Here's how it's going to go. The first one, we're going to talk about domain and range, what that really means in the context of trigonometry, why trig is written in functions and what that means for you practically, how we use that to find an angle, how we find sine, cosine, tangent, all that kind of stuff. So let's get to it. So the first thing you got to understand is that trigonometry is written in function notation. The way function notation works is the very first thing you see is the name of the function. Now normally in algebra, they're just f or g or h or k or something like that. The input is just x. The domain kind of doesn't really matter so much unless you're dealing with something rational or a square root. And the output is something that is calculated. Like you plug in a number, you do the order of operations, and then you get the output. But trig, it's a little different. In trig, we have 3 main functions: sine, cosine, and tangent. That's how you pronounce them: sine, cosine, and tangent. A lot of the time people say sin, cos, tan, but what they're actually doing there is reading the abbreviation. Here's how the abbreviations look: sine, cosine, and tangent. The input, theta, that's the Greek symbol theta right there, that slanted circle with the slash through the middle. That's just the input. It's a variable, just like x or y or anything else. But that's how it's written: sine, cosine, and tangent of an angle. So when we start talking about what these functions mean, we have to understand that the domain, the set of values that could be inputs, the domain is an angle. And not just an angle, it's an angle from a right triangle. Now it's true, you can do sine, cosine, and tangent of angles that are negative or more than 90. But strictly speaking, sine, cosine, and tangent, those are trig functions defined for a right triangle. Now we'll learn how all that other stuff works with the angles more than 90 or negative in, I think, the second and third. We're going to do them both. But for now, we're going to talk about just right triangles. So let's get to it. With sine, cosine, and tangent, what you're doing is you're saying that there's an angle in a right triangle, and the output is the ratio of sides of that triangle. So sine is opposite over hypotenuse. Hypotenuse is always the longest side. Cosine is adjacent over hypotenuse. And of course, tangent, as you can see, is opposite over adjacent. Now, one of the trickiest things for students when they're first learning this is, well, the hypotenuse is easy, but opposite and adjacent, well, what those sides really are changes depending on what angle it is that you're speaking of. So for example, the hypotenuse is opposite of the largest angle. The shortest angle, the smallest angle, this one over here on the right, is opposite of the shortest side. Adjacent to it, adjacent to this angle right here, are the hypotenuse and this side. This side would be called adjacent to this smallest angle. Whereas if we look at this middle-sized angle right here, opposite of it is the middle-sized side right here. And adjacent to this middle-sized angle is this shortest side right here. So adjacent to this angle, shortest side, and the hypotenuse. And so one thing you got to understand is the hypotenuse is adjacent to either of the sides, or the hypotenuse is adjacent to either of the angles that we're going to be talking about, but we don't call it adjacent. The 2 legs of the right triangle, they're adjacent to the 90-degree angle. So one way to think about it is adjacent sides make the angle. So let's talk about these angles here, x and y, just to get a feel for how this works. So when we talk about angle x right here, the opposite side is n, and the adjacent side is m. Now it's true the hypotenuse is adjacent, but because the hypotenuse is always the largest side, it's fixed. We just call that hypotenuse. So adjacent is going to refer to one of the other sides, the one that's next to the angle. So which side is adjacent to angle x? M. Which side is opposite of angle y? M. Which side is adjacent to angle Y? Adjacent is next to, that's N. And the opposite of angle X is also N. So N could be adjacent or it could be opposite. Depends on which angle it is you're speaking about. Now, when we start talking about sine, cosine, and tangent, sine is defined as opposite over hypotenuse. It's not something that's calculated, it's something that's actually measured. So the sine of angle X is opposite over hypotenuse. So the sine of angle X would be N over the hypotenuse. And the cosine of angle X would be M over the hypotenuse. Tangent would be opposite over adjacent. So opposite of X is N, adjacent is M. So the tangent would be N over M. Now, quick question for you. Why is it that the sine of an angle is going to be 1 or less? It's actually going to be between 1 and -1. Do you know why? Well, when you look at sine, remember, it's the opposite side. We'll do an OPP here, over the hypotenuse. The opposite over the hypotenuse. Now, here's the thing. The hypotenuse is always the biggest side. It's the largest number. Whereas the opposite side is going to be smaller. So when you divide a smaller number, like 7, by 10, you end up with less than 1, always. Well, that's supposed to be a 0.7 right there. Anyway, when you divide by a small number, by a larger number, you always end up with something that's less than 1. So that's why sine, cosine are both in between negative and positive 1. Now, how they become 1 or -1, we'll learn in part 2. But as we're saying, the hypotenuse is the longest side. So when you talk about the sine of this angle is opposite over hypotenuse, this side is smaller. Now, SOHCAHTOA, fantastic. That's what I always use to remember. It just keeps me from getting into any trouble. So SOHCAHTOA is an acronym. It's sine is opposite over hypotenuse. See, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is a good way to always remember how these trig functions are designed. So sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, and then tangent is opposite over adjacent. So let's do a little exploration here into let's do an example, okay? So we got sine of C, cosine of C, and tangent of C. And then we have sine, cosine, and tangent of A. So C means the angle whose vertex is C. It's right here. And A is the angle whose vertex is A. So that's this one right here. All right, so sine of C is opposite over hypotenuse. So opposite is 15, hypotenuse is 17. So that's going to be 15 over 17. Now cosine is adjacent over hypotenuse. Adjacent is 8. 8 is adjacent to angle C, and the hypotenuse is 17. So cosine's adjacent over hypotenuse. That's 8 over 17. Now, tangent, opposite over adjacent. So opposite is 15, adjacent is 8. So it's 15 over 8. Now let's talk about sine, cosine, and tangent of angle A. So A, the opposite side is 8, and the adjacent side, the opposite side is 8, but the hypotenuse is 17. So that actually turned out to be what the cosine of angle C was. Now angle C and angle A, they're called complementary because they add up to 90 degrees. Angles that add up to 90 degrees are called complementary. So the sine of an angle is the same as the cosine of its complement, or the cosine of an angle is the same as the sine of its complement. So this 8 over 17 is the cosine of angle C. It's also the sine of angle A. Just like that, you see. Now, same thing here. The cosine of angle A is the adjacent divided by the hypotenuse. Well, adjacent to A is the same as opposite of C. So 15 over 17 is going to be the cosine of angle A, or the sine of angle C. Just like that. Now, the tangent, it's the reciprocal. It's flipped over, do you see? So opposite over adjacent. Opposite is 8 over adjacent is 15. The thing I really want you to get to, the takeaway I really want you to have is that opposite and adjacent are relative to the angle you're considering. So the opposite of A is the same as the adjacent of C, but the adjacent of A is the opposite of C. And so you just got to be really careful not to mix that up. Adjacent makes the angle. It's right next to it. Opposite's the side of the triangle that doesn't form that angle at all. And so adjacent, just like that. All right. Tangent, just like that, I mean to say. All right. Now, the way functions work is you have an input and you have an output. If you need to solve for the input, you actually cannot use inverse operations. So for example, here it says the sine of this angle with the question mark. Which angle has a ratio that is 36 over 45? Now, the reason I know what this ratio is because right here it says sine, and sine I know is opposite over hypotenuse. So which angle has an opposite side that is 36 and a hypotenuse that is 45? Well, it looks like that would be angle X. The opposite is 36 and the hypotenuse is 45. So I would say that the sine of X is this. Now it says cosine of what is 36 over 45? Well, cosine is adjacent over hypotenuse. So which angle is adjacent to this side, 36? Well, that would be Z. So I think this would be Z. And then it says tangent. 36 over 27. So opposite over adjacent. So which one's opposite of 36? It's not Z, it's X. Now, is 27 adjacent to X? It is, and it's in the denominator. So that's how those work. Now, the way you write it is with inverse functions. Like this right here. And if you don't remember, that little exponent, a -1, means an inverse function. And then the thing with an inverse function, the big idea, the fundamental concept is that the input and the output are switched. So with the regular sign, the input is an angle and the output's a ratio of sides. With arc sine, that's how you say it, ARC, arc sine, which is the inverse of sine, the input becomes the ratio and the output becomes the angle. So if you have a fact like this and you need to find what is the angle, what you do is use the inverse function, and that's all programmed in your calculator. So you could actually plug this into your calculator and figure out what the actual angle is. From the diagram, it's angle X. So again, the way we say inverse of sine is arc sine. It's arc sine, arc cosine, and arc tangent. All right? So can you figure out which angle has a sine of 1/2? Can you do it on a calculator? This is what you would type in right here. The sine, this is the sine of what angle is 1/2. That's the way this says. So arc sine of 0.5 is equal to what angle? Go ahead and plug that into your calculator if you have one right there. Pause the video, see what you get. All right, so we're going to finish this one up with a conceptual question. I'd like you to try this. And then this is going to tie in directly to the next part. So what I would like you to do is get a compass, or actually a protractor, and make a triangle that's a right triangle, and make it so that the cosine of one of those angles, A or B, actually the angle B, is 1/2. So you're going to use A, B, and C. C is, of course, the 90-degree angle. So can you construct a triangle whose cosine of angle B is 1/2? Once you do that, I would like you to measure the hypotenuse and see what you got.